All right, so Gemini 3.6 Flash just ranked number 2 out of 190 models for raw speed, and Grok 4.5 is sitting at number 5 for intelligence. Two very different animals, and I wanted to find out which one actually earns your API budget. Both models dropped recently. And the pricing and capability gaps are real decisions you're making right now. So I'm running Gemini 3.6 Flash versus Grok 4.5 across 4 concrete tests: speed, pricing, coding, and math, and long context retrieval. Every number comes from independent sources, no vendor spin. And honestly, the thing that surprised me most was how the pricing flips depending on one specific thing about your workload. And getting that wrong could cost you a lot of money. So this comparison is for developers and teams actually picking a model for production work, whether that's an agentic pipeline, a coding assistant, or long document analysis. The wrong pick can mean paying more per request, hitting context limits mid-task, or getting worse code out the other end. That's real money and real time lost. Test 1: API latency and throughput. When your pipeline is literally hammering a model with thousands of requests, slow output speed stacks up fast, idle wait time, user-facing lag, agentic loops grinding down, a 2 times speed difference at scale means a completely different cost structure. I pulled the numbers from Artificial Analysis and Gomel.io, and the gap is wider than I expected. Gemini 3.6 Flash clocked 235.4 tokens per second on a 10,000 input workload, and Grok 4.5 came in around 90 tokens per second, so more than 2.5 times slower on output generation. These are different test rigs, so treat it as directional, not a clean head-to-head. Now, Grok 4.5 actually gets to its first output token faster, around 13.8 seconds, versus Flash's 19 seconds. So if you're in an interactive app where a user is staring at a blank screen, Grok feels more responsive at the start. The throughput gap only really compounds when you're pushing volume, not for a single conversational turn. I was expecting Grok to be close on speed given XAI's claims, but 90 tokens per second versus 235.4 is not close at all. Gemini 3.6 Flash takes test 1 on throughput, and it's not really a contest for high volume work. Flash up 1-0 on the running score. Test 2: pricing per million tokens. This one's sneaky because you can pick the wrong model and not realize it until your bill shows up. If your app generates a lot of output, like long code completions or verbose reasoning chains, the per output token rate matters way more than the input rate. And getting that ratio wrong can mean paying 20 to 25% more than you need to every single month. Neither model is cheaper across the board, which is kind of interesting. Gemini 3.6 Flash is $1.50 per million input tokens versus Grok's $2. So Flash wins on input by 25%, but on output, Grok is $6 per million versus Flash's $7.50. So Grok wins there by 20%. And Flash's cached input at 15 cents versus Grok's 50 cents is a pretty big deal if you're reusing context a lot. Honestly, I was expecting one model to just be cheaper, but the pricing actually flips depending on your input to output ratio, which is kind of annoying. So this one's a genuine tie, and there's no single right answer without knowing your workload. Score stays at Flash 1, Grok 0, with 1 tied. Test 3, coding and math reasoning. When a model fails here, you get a bug that ships, a refactor that breaks things, or an agent stuck in a loop because it couldn't reason through the next step. If you're building anything that writes or reviews code, this is probably the dimension you care most about. I looked at the DeepSawi benchmark numbers and the Artificial Analysis Intelligence Index, and here's what we got. Grok 4.5 scored 62% on DeepSawi pass at 1, while Gemini 3.6 Flash came in at 49%. So that's a 13-point gap. On the Independent Intelligence Index, Grok scores 53.83 and ranks 5th. Flash scores 50 and ranks 26th. The DeepSawi runs use different harnesses, so treat it as directional. Flash isn't standing still here though. It jumped 12 points on DeepSawi from its prior generation, which is pretty interesting. And there are benchmarks like MLE Bench and OS World where Flash has published numbers, but Grok doesn't. So the comparison isn't fully symmetric. The 13-point gap is real, but it's not the whole picture. I was expecting Flash to be closer given how much it improved from the last generation, but Grok 4.5 takes test 3 pretty clearly. 62 versus 49 on DeepSawi and a higher independent intelligence rank, that's Grok winning on reasoning depth. We're tied up now. Flash 1, Grok 1, 1 tied. Test 4, context window and retrieval fidelity. When you hit a model's context limit mid-task, you get a broken workflow, chunking documents manually, managing state yourself, hoping nothing falls through the cracks, for large code bases or long legal documents. Running out of context means a full pipeline redesign. What surprised me here is how clean the gap is. Gemini 3.6 Flash has a confirmed 1,048,576 token context window. So basically 1 million tokens, and Grok 4.5 tops out at 500,000. That's exactly half. Flash also scored 1421 LO on the GDP bow retrieval benchmark versus 1349 for its prior generation, which is a solid independent improvement signal, though there's no shared retrieval benchmark to compare Grok directly. Now, Grok 4.5 completed a reconstruction task using only 29% of its 500,000 contexts in an internal pilot, which suggests it retrieves efficiently within its limit. So if your workload fits inside 500,000 tokens, Grok's retrieval quality might be totally fine. The two models have no shared long context benchmark in the reviewed data, so the window size comparison is the clearest signal we've got. I was expecting this to be closer, but a 2x context window is just a 2x context window. Gemini 3.6 Flash takes test 4. 1 million tokens versus 500,000 is a real structural advantage for long document work. That brings us to Flash 2, Grok 1, one tied going into the final call. So where does Gemini 3.6 Flash clearly win? Speed, context, and cost efficiency for input-heavy work. It's 235.4 tokens per second, ranked second out of 119 models, with a 1 million token context window that's twice Grok's limit. Input at $1.50 per million versus $2, cached input at 15 cents versus 50 cents, and no per call tool fees eating into your agentic pipeline budget. And where does Grok 4.5 clearly win? Raw reasoning on hard problems. It scores 62% on Deep SUI versus Flash's 49%, 64.7% on SUI Bench Pro, and 83.3% on Terminal Bench. Output tokens are $6 per million, 20% cheaper than Flash's $7.50. And it gets to its first output token in about 13.8 seconds, which is faster for interactive use. Honestly, I went in thinking one of these would just dominate, but they're genuinely built for different things. So here's the decision rule. If you need high volume throughput, long document context, or low input and cache token costs, go with Gemini 3.6 Flash. If you need the best reasoning on hard coding and math tasks, and your workload is output heavy, go with Grok 4.5. These two aren't interchangeable.